Welcome to Kotlin. This video is part of a series where we're building Minesweeper with Compose Multiplatform. Whilst it's designed to be useful on its own, there may be some references to earlier episodes. Start by adding DataStore to your TOML file. You can find the latest version in the description. Next, add this as a dependency in your build.gradle file of your module. Create a file named create_DataStore within your common main source directory. Within this file, create a function matching the file name. This is the function that will create the data store. It will have a lambda parameter named producePath, which can be used to provide the file path of the DataStore file. The return type should be a data store with a generic type of preferences. We can use the factory provided by the DataStore library to create the data store with a path. Don't forget to call toPath on the string provided by your producePath lambda. Create a constant string of your file name that you can use across each platform. This must end with .preferences_pb as seen on screen. If Android is a target platform, create a file within the Android main source directory named create_DataStore. Within this file, create a function that takes a context object as a parameter. This allows us to resolve an appropriate file path for storing our DataStore file. This function calls the function created in the common main source directory, and we resolve the path using the files directory that's gotten through the context object. If iOS is a target platform, create a file within the iOS main source directory named create_DataStore. Create a function named create_DataStore that calls our common main function with the same name. Within the producePath lambda argument, we first need to get the document directory and then append the DataStore file name to the end of its path. Copy the parameters shown on screen, or here is the documentation if you'd like to pause and read what each of these are. And lastly, we get the path for the document directory and append the DataStore file name. Depending on the version you're using, you may need to opt in to the experimental API. If desktop is a target platform, create a file within the desktop main source directory named create_DataStore. Create a function named create_DataStore. This will call our common main function with the same name. First, we'll get a reference to the user directory or wherever you'd prefer to store the file. If the folder doesn't exist, then we'll create it. Next, we'll create the path to the DataStore file by appending the file name using the file constructor. Then we can forward this function to the function we created in the common main source directory and pass through our path. To initialize the data store in Android, simply call the Android function we've created and pass in a context object. Note that you may use your application context for this case. To initialize the data store in iOS, simply call the iOS function we've created, which does not have parameters. And similarly to iOS, to initialize the data store for desktop platforms, call the desktop create_DataStore function that does not have parameters. Now we're going to look at how we implemented this in MinesweeperK, including how to access preferences using keys in the form of observables using Kotlin flows, but also how to access them immediately using coroutines. Right, so we've started by following all the steps previously mentioned in this video, and for MinesweeperK we've done this within the core module of data. So this can be accessed by every other module within data, so game and settings. This allows us to use the same preferences database between them. So if we just have a quick look here, we've put this in a package named storage within this module. And as you can see, it just follows what we've done earlier. We'll look at the Android as well. But yeah, these aren't being used at the moment. So the first thing we're going to do is we'll open common main for the data core module, and within this package we're going to create an interface named storage. Now this is just going to allow us to abstract out everything about getting our preferences. So first thing we'll need is a class which we'll name key, and this will give a generic type. So we need the name that's going to be used to access the value, and we'll give it a default value which will be the type, and this will be nullable. Next we'll need a function to actually get the value from the data store. So this, it's going to return this generic type. So we can say get as flow, and this will take a key with that type and return a flow of a nullable t. Next we'll want a suspended function for, this is going to be for getting the value immediately. So we'll just name that get. We'll need a key for that, and this will just return a nullable t. Next we'll want a function to write the value to update what's stored. We'll just name this write value. This will need a key. Sorry, this needs a generic type. And here we can pass in the value. We'll make that nullable so it can be written to be null. And we'll just create a little helper function here and just say clear value, where we can pass in the key, and all this is going to do is just call write value with the key, and we'll just pass in null. And next we'll create our implementation of storage using the data store. So we'll create a new file and we'll call that DataStore storage, and this will implement our storage interface. And this will need a parameter in the constructor which will be our data store. So we can say private file data store, and this matches what we're creating within here. So this is what's eventually going to be passed through into our data store storage. So within here we can say datastore.data, and this needs to be mapped. So then what we have here is our preferences that's coming through. Now we need to be able to get our value that matches the generic type that we're using. So this is where it gets a little bit complicated. We'll have to go back into storage, and we need to be able to know which type this is. So to do that, we'll turn this into a sealed class, and within here we can create a class that matches each type that's available in preferences. So that'll be string, int, long, float, double, and boolean. So in MinesweeperK we're only actually going to use the string, but just for completeness sake I'll add them all here. So to add the string, we'll say class string key, and in here we'll still pass the name. So this is the name that's actually used to get the key, and we'll add a default value. But here we can explicitly say that it's a string. We'll make that nullable to match what's here, and this will inherit from key with the type of string, and then we can just pass through the name and default value. One last thing, we'll make this an open class, because what we're going to do later, it might be easiest just to wait till then, but say in our case we're going to have a key to get the username of the user. We'll end up with something along the lines of object username key, and this will inherit from string key, passing through the key name for the username and whatever default value we like, so something like anonymous. So yeah, that's why we need this open. Now I'm just gonna quickly add through every case we need, so the types that I just listed before, but I'll speed this up. So next we'll go back to our DataStore storage class and we'll create a function, because what we're going to need to get is we need a preferences.key instance to pass into this preferences.get function. So here we'll create a function using a generic type. We'll just say get DataStore key, and this we can pass our instance of our key and return a preferences.key instance. So here we'll use a when statement. We'll say when key, because since this is a sealed class, we can just let it autofill all of the possible instances, all of the class types, and within here we'll say boolean preferences key. We can pass in key.name. Now we're just going to do this for all of the different types. So here we'll have double, float, int, long, and string. Now this is, if we look here, this is returning explicitly preferences.key with a type of string in this case, be long for this case, and so on. So what we need to do is cast this to our type. Now this is warning us that it's an unchecked cast, so we can suppress this for the function. Now it's okay to suppress the warning in this case, as by using the sealed classes in the way that we're using them, we're logically ensuring that these casts will always succeed. The warning appears because type T is erased at runtime, so the compiler can't guarantee that this cast is going to exceed. It might feel like a workaround rather than a proper solution, but there's nothing strictly wrong with doing it this way. That even though we're certain that it's going to succeed, the compiler just can't guarantee. So that's why it's warning us as it should. But yeah, we're just suppressing this locally, and now we can actually use this function. So back up here, we can say get DataStore key and pass in our key. One last thing we'll do is, if this is returning null, we'll return key.default value. Now for the suspended function, we can simply just call our getters flow, pass through the key, and say first on null. And also similarly to what we did here, we'll want to fall back to key.default value. Now for write value, we can say datastore.edit, and here we'll have this mutable preferences. We'll name this preferences. Well, first of all, we'll say if value is null, then we can just do preferences.remove, and we need we'll extract this out up here. So we'll say val key equals get DataStore key. And here we'll remove the value. We'll name this DataStore key just so that it doesn't match the name here. So if the value is not null, we'll just set it inside the preferences, and that should be everything we need for our DataStore storage. Next, we need to actually initialize our instance of storage. So we'll do that within our coin modules. So we're going to need to initialize the DataStore depending on which platform we're on in a different way. So what we can do is say internal expect val We'll call this platform module. So everything that's platform specific can be declared in each separate platform module. And within here, you can say it includes platform module. So we need to match this in each source. So here we'll say create a file named module. We can say internal actual file platform module, and in here we need to create the data store. So we'll say single data store with a type of preferences, and create data store, and we'll get the context. Now this context that we're injecting here, if we go through to main activity, we'd already added this in a previous episode, but within this platform module that we're passing through to the app composable, we're declaring the application context here. The application context is fine to use to get the files directory. So next we need to do the same thing for the other platforms. So we'll go to desktop next. Create a file named module, internal actual file platform module. Here we a single data store with preferences, and just call the function with no parameters. And we're just going to copy this code because it's going to be identical for iOS. Create a file named module, and this should be calling the iOS specific function, which it is. So we'll just run this and check nothing breaks. And yes, it does, because we've got the duplicate JVM class name. So this is conflicting between desktop and Android. To fix this, we can simply rename our Android file to module.android.kt, and we're going to need to do the same for create data store. We'll change that, and we'll do the same for desktop. And it's still running fine. So now we'll just quickly create a settings screen so that we can check it works. So we'll just create that within the settings feature module. Name it settings screen with the matching composable. This will just be a column, and within this we'll just have a text field that needs the username. We'll just leave this blank for now, and value changed again, blank for now. We'll sort that in a few minutes. We'll have a button, and this is going to save the new value, and we'll just give this text of save. We'll just add a little text label above this text field saying username. So we'll create a view model to go alongside this settings screen. That'll inherit from view model. Now we need a way to get our username and also to update it. So we're going to do that using use cases that will live in the appropriate domain module. So we'll work backwards here, and we'll type them here first. So we'll want get username as flow use case, and we'll want a way to update the username too. So we update username use case, So that's everything we need for in the view model. Now we'll actually create these. So these will be created within the settings domain module, and they'll just match these names, so we'll copy that. Now what we're going to need passed through here, so again we're working backwards, is our username repository. We haven't created this yet, but we'll just type this through first. So now we need to move along to the data module, so data settings, and within here we can create our username repository. This will be an interface. If the way these modules are set up aren't making sense, I'd recommend looking back at the earlier episode where we talk about the module structure. So now that we've created the username repository, so this is the interface. All we need here is the username, which will be a flow, and we currently don't have this dependency added, so we'll add that now. Within the data settings module, to implementation, and in the TOML file we've got a bundle named Kotlin which has all of these, but this is what we're looking for. The coroutines core includes everything with the flows, so we'll sync that, and now we can import this. So the other thing we need is a suspended function for updating the username, and that will just take in a string. So next we'll create our implementation of this username repository. We'll just name this default username repository. And this just needs an instance of storage. And it will implement username repository. And from here we can just call storage.getAsFlow. Now we need a key here. We'll add the key within the username repository interface. So here we can just say data object username key, and that will inherit from storage.key.stringKey. Here we can just give a name of username, and we'll add a default value of anonymous, just for if no username is set. So we go back to default username repository. We can now pass this key through. Now this needs mapping, as this isn't expecting a nullable value. So here we'll just simply say it.orEmpty. Now for updating the username, we can simply forward this call through to storage.writeValue, and again using the username repository.username key, we can then just pass the value. Now we need to actually add these to our coin module, so we'll do this here inside our data settings module. We'll say single of the default username repository, and this will be bound to the type of username repository. We'll import these functions. So now that's added. So now we can follow this back, so we can go into our get username as flow. Now we can import this, and we'll add operator fun invoke, and this will return a flow of string. Similarly, we need to add the Kotlin dependency to the domain settings build.gradle. That's this one. for this we'll just equal username repository dot username. We'll import that, and that's everything we need for that. The only thing we need to add is we need a factory of this use case within our module, our coin module. So here we can say factory of, and pass in the get username as flow use case. And we can use : to access the constructor directly and pass this in. Now we'll create our other use case while we're here, and we'll name this update username use case. This will also need the username repository. Now this will be a suspended function, also operator because we're using invoke here. And this will take in the username that's wanting to be set, and we can simply forward this on to username repository.update username. We'll add this to the coin module too, update username use case, and that should be everything we need. So now we can go back to the view model. So back into settings view model, we'll import the two use cases, and now we can get the values we need and update them. So we'll start by adding a function, we'll just name it save. And within here we'll need view model scope. We can just call update username use case, and we need to get the username from somewhere. So we'll just create a variable named username. This will be a mutable state flow. That's just going to hold the username that's on screen. We can get that using username.asStateFlow. So now here we can just pass in the username.value. Now what we need to do is populate this username with what's already stored. We'll do this within init. We can say view model scope, and we'll get the username as flow. And we'll just get first on null, and if this exists we can just set this value to equal it. Now we'll link that up to the settings screen. So first we need the view model to be passed through. Then we can get the username by viewModel.username.collectorState with lifecycle, and import that function. Now we'll pass that through to here. Now on value changed, we'll need to say viewModel. We'll name this set username and pass through the new string. And we'll create that function now. And all this is going to do is just update the mutable state flow with the value that's passed through. Now back to here, the last thing we need is the on click for the button. We can just say viewModel.save. So now we need to go back to the feature module, and we'll actually need to create the routes so that we can access this from the other modules. So first we'll call this settings routes. Within here we need a serializable data object. So this is what we'll use to actually navigate to the settings screen. We'll create an extension function on navgraph builder just called settings routes. within here we can create the composable with our settings type. We'll get the view model, which I've just realized we need to add into our settings coin module. So we can say view model of, and get the settings view model. Now we'll pass this through to settings screen. We'll say modifier, and we can just fill max size so that takes up the whole screen. So now if we go to our app composable, we can declare our settings routes in a similar way to the high scores routes, and within the menu routes where we've got our go to settings lambda, simply call navcontroller.navigate and pass through our data object, the settings. So we'll run this. If we click settings, it doesn't work because it couldn't create get username as flow use case. So we'll follow this through. It couldn't create default username repository, and that's because we haven't declared our storage. So if we go back to data core, yeah, as you can see, we need to declare it here. So we'll say a single of our DataStore storage. That should be bound to storage. Import that, and we need to import DataStore storage and the function. Now this should work. Yep, so it doesn't look the nicest, but we have the username label and the text field. I made a small mistake when creating the file name. If we go back to create DataStore in the common main source directory, I've used .preferences underscore db. This should be pb as so. I'll rerun this and we shouldn't see any errors show up. Yep, so as you can see, that was the default value that we set, which is anonymous. So we'll just change this to Bob and save. We don't have a way of going back at the moment, so I'm just going to stop running this and reopen. But as you can see, Bob is now saved. Now this should be everything you need for using DataStore. A lot of this has just been abstracted behind our storage interface, which isn't really needed for the tutorial on DataStore, but it's just how we've done it in MinesweeperK. Next week we're going to add some tests into the project, and we'll take a look into how to do UI tests with Kotlin Multiplatform. If you've enjoyed the episode or the series so far, be sure to subscribe or even star the repository on GitHub. Just anything will help. And thanks for watching.